Solving an equation for a specific variable can make it easier to solve a real-life problem. Here's one example. The Department of Streets of a city has a budget of $1,962,800 for resurfacing roads and hiring additional workers this year. The cost of resurfacing a mile of two-lane road is estimated at $84,000. The average starting salary of a worker in the department is $36,000 a year. Write an equation that represents the relationship between the miles of two-lane roads the department could resurface, M, and the number of new workers it could hire, P, if it spends the entire budget. The total budget is $1,962,800. That amount equals the total cost of two-lane highways that can be resurfaced, plus the cost of the salaries of all the new workers the department could hire. Because $84,000 is the cost to repair a mile of road, and M is the number of miles, 84,000 M is the total cost to repair the two-lane roads. Similarly, the annual cost of a new worker is $36,000, so the cost of P workers is $36,000 P. The resulting equation is $1,962,800 equals 84,000 times M plus 36,000 times P. Now, use inverse operations to solve for P. First, subtract 84,000 times M from both sides. Next, divide both sides by 36,000. Now we can see that P equals 1,962,800 minus 84,000 times M all over 36,000. What does this solution represent? This equation will tell how many workers can be hired while paving M roads and remaining on budget. Now let's solve the original equation for M. Start by subtracting 36,000 from each side. Next, divide each side by 84,000. Now we can see that M equals 1,962,800 minus 36,000 times P, all divided by 84,000. What does this solution represent in the equation? M gives the number of miles of two-lane highways that can be paved while hiring P workers and remaining within the budget. Which equation should the department use to find out how many miles of two-lane roads it could resurface? When the number of workers, P, is known, this equation would be best used to find how many miles should be resurfaced.